Okay, good day everyone. So I am presenting my research entitled Arduino-based multiple temperature selection thermoelectric water dispenser. So these are my outline of presentation of my study. I will begin with the introduction, then we have methodology, and then results, and lastly conclusion. Okay. So this research is about developing a water dispenser that offers consumers with a wider range of temperature selection to cater the various drinking temperature preferences of different people. So this design uses thermoelectric module, which operates based on the Peltier effect to heat and cold water in the respective container, thereby eliminating the harmful effects of Freon, a refrigerant used by current water dispensers for cooling process. The implementation of Arduino Uno as microcontroller provide consumers with a chance to input and be served with their desired temperature. So let's go to now the objectives. Or rather the statement of the problem. So existing water dispenser design is seen to be less versatile as it only dispenses hot and cold water and does not provide temperatures in between. So our objective of the study is specifically, this study aims to meet the following objective. So develop a water dispenser using thermoelectric module as heating and cooling element. So develop an accurate water dispenser that will provide consumers with multiple water temperature selection. So design a low energy consuming water dispenser that will enable consumer to save money by replacing heating element compressor and condenser with a filter thermoelectric module. Okay, so let's go to the scope and limitation. So this is only limited to 1 glass per dispensing. So this study is primarily made to innovate the design of the present water dispenser that is found to be needing development and improvement. Also, purification of the drinking water is not included in the study. Additionally, the dispense volume is set only to 1 glass every time the push button is pressed. Okay, let's go now to some literature review from the existing literatures and related studies. So let's go to consumer water temperature preferences. So as said by Catriona Bordan et al., conducted a study to provide systematic and unbiased review of the research on how beverage temperature affects palatability and fluid intake during endurance exercises. So their study showed that the colder beverage whose temperature ranges from 0 to 22 degrees Celsius tend to be more palatable and thirst quenching compared to warm beverages whose temperature ranges from 22 to 46 degrees. Furthermore, cold beverage served at 10 to 20 degrees Celsius appears to be preferred temperature range for fluid replacement during an exercise in temperature to warm environments. So according to Ranji Patna, coordinator of a preventive health check at Fortis Hospital, Mohali, water temperature when swallowing medicine should ideally be at room temperature. And in the case of those with a cough and colds, it is advised to take medicine within lukewarm water. So another literature from H.S. Lee and Mahoney sought to answer the question on what temperature do consumers like to drink coffee. 300 consumers were required to mix a hot and colder coffee until it was the desired temperature for drinking. Results from their experiment show that the consumer tend to choose an average temperatures that were above those published for oral pain and epithelial burn damage results. They concluded from the results of their experiment that the chosen preferred temperature for drinking coffee was around 60 degrees Celsius, or that is around 140 degrees Fahrenheit. So let's go now to the methodology. So the overall methodology of this research follows a step-by-step process according to decision rule algorithm. Okay, so the algorithm is initiated by if-then loop statements, and which should be constituted as a variable mainframe for the processing trait of the whole system. Okay, so we have here a Peltier module embedded in our water dispenser. So we have here extract data from the DS8NB20 sensors. This is our digital temperature sensor used in correlating the temperature of the hot and cold dispensed by the water dispenser. And this is the decision rule algorithm. And we are employed in our set threshold. And then we use Arduino Uno as a microcontroller that will actuate the water pump in the cold tank and operate for a period computed cold over dispense time. Okay. So this is basically now the hardware design of the study. So let's go now to the results and discussion. Okay. So we have tested the accuracy based on our temperature sensor. So we have here temperature hat, that is pH, that is 52.2 degrees Celsius, and then a temperature of cooling is 13.8 degrees Celsius. Okay. So we have also set test the accuracy using the thermometer. Okay, and then we have correlate that the results of our digital temperature sensor, and then we have concluded that the results of our temperature sensor is accurate. So the recorded dispense time is reasonable. Okay, when the set point temperature is closer to the temperature of the water inside the hot tank, the dispense time for hot water is longer than the cold. However, when the set point temperature is closer to the temperature inside the cold tank, the dispense times for dispensing cold water is longer than that of the hot water. Okay. So we have also get also the power consumption, and then compare it to the existing manufacturing of the water dispenser compared to the modeled water dispenser, the Arduino-based multiple temperature thermoelectric water dispenser, which is a very energy consumption compared to those of brands offering water dispenser in the country. Okay. So we have also gained experimental results. Use basis in computing for the system accuracy. Average error was chosen for tool for evaluating the test results. So comparatively, all the products mentioned, energy consumption greater than the rated energy consumption of the Arduino-based multiple temperature selection thermoelectric water dispenser. And then also in the test of the accuracy, so we have also verified that the designated water dispenser is low powered. Benchmarking was conducted, and of the top 5 selling water dispenser in the country, and we have compared its energy consumption and its design. Okay, so we have used, particularly in this study, we have used the thermoelectric water dispenser, which is energy saver for as compared of the top 5 brand we have in the country. So let's go now to the conclusion. So it was found out that the design of Arduino-based thermoelectric water dispenser can cater different water temperature preferred by different kind of people. This design water dispenser has also achieved a lower power consumption compared to the leading water dispenser in the country. So thus the design concept was successfully done. So on the recommendations, so this study can be further improved and implemented by using keypad instead of the potentiometer to provide customers with a more convenient and less consuming time way of inputting the desired set point temperature. So lastly, the study can be best improved if the total volume dispensed every time the push button is pressed is not limited only to 1 glass. Additionally, future researchers can improve this innovative design by creating a much better heating and cooling design and temperature control system. And that's all. Thank you very much.